Hi everybody, so today's lesson is going to be about the properties of parallelograms. The last few days we've been talking about polygons, and so now we're going to look at a very specific polygon called the parallelogram. Love parallelograms. In order to do that, first let's just define what family the parallelogram falls in. The parallelogram is in the family of what we call quadrilaterals, and a quadrilateral is a four-sided polygon. And you may remember a few things about polygons. They are figures made up with lines or segments. So like a circle is not a polygon. A quadrilateral, the word quad means four, so a four-sided polygon. All right, so let's discuss this special polygon, the parallelogram. A parallelogram, by definition, sorry about that, guys. A parallelogram by definition is a quadrilateral, so a four-sided figure, a four-sided polygon, with both pairs of opposite sides parallel. And there's me using the parallel symbol, okay? All right, so, and you have a place you can put that in the definition slot. All right, now, a couple of things that we need to know, and we're going to write this like using an if-then statement. So if I tell you something's a parallelogram, so if I say ABCD is a parallelogram, and I'm going to use the symbol, so the symbol for parallelogram is a slanted rectangle that looks like a parallelogram, and I'm going to put a P in the middle of it. That just helps me remember parallelogram. ABCD is a parallelogram, then AB is parallel to BC, and BC is parallel to AD. All right, so we're going to label this parallelogram ABCD, parallelogram. So I would say parallelogram ABCD. So for us, I mean, you pick one of the vertexes, it doesn't matter which one, and then you make sure that you follow proper order. So you can't jump around. You can't go A to B to C to D. You have to either go clockwise or counterclockwise. But for our class, what we're going to always do is we're going to start in the top left corner and we're going to go clockwise. So that way we all have the same diagrams. But again, you can use whichever ones you want. But that's how we're going to do it for our class, okay? All right, so the symbol for drawing with the symbol, I just want to make sure everybody got that the symbol we'll use is this parallelogram. We would say parallelogram ABCD. As soon as I know it's a parallelogram, one of the things I'm going to be able to say then is that these opposite sides are parallel, and so I would mark them parallel. Okay? All right, so let's move on and use this, okay? All right, there are some properties of parallelograms that we're going to talk about, and although these are not the definition, these are properties. The definition is going to help us prove them to be true. So the first property is the question I ask you: are opposite sides of a parallelogram, are they congruent, and why? All right, so how do we determine if that's actually true? So we're going to start by looking at the given, a proof. We're going to prove that opposite sides are parallel. So the first thing you may notice is there's no, and I'm going to put a little P in there. You're going to notice that there's no diagram. So the first thing I'm going to do is I'm going to draw parallelogram EFGH. Now, I want you to make sure they're slanted and you're not drawing rectangles, because a rectangle is actually a very specific type of parallelogram, so make sure they're slightly slanted. All right, so there's my parallelogram, and as soon as we see that it's a parallelogram, then we know that the opposite sides are parallel. So I'm going to mark my diagram with what I'm given. Okay, so there's my parallel. All right, so one thing that you have to know is that you're allowed to draw a line in any figure. And so in order for us to prove these segments congruent, we actually are going to have to do that. We're going to draw in one of the diagonals, just one. So I'm going to draw a line segment from E to G, and I'm allowed to do that. Now you may notice that I turned it into two triangles. So in order to prove that these segments are congruent, EF and HG and FG and EH, we're going to use congruent triangles. We're going to use congruent triangles. Okay, so I drew my figure. I've got my parallel lines marked. I'm actually gonna help myself. I'm gonna put in 1, 2, 3, and 4. So if those lines are parallel, that means that angle 1 is congruent to angle 3 because they are alternate interior angles, and also angle 4 is congruent to angle 2 because they are alternate interior angles. All right, then we go to our list of what we do to prove triangle congruence, and you may all see that we added that diagonal, which is the reflexive side. So hopefully you can see that you can prove the triangle's congruent by using angle, side, angle. All right, so let's do it. Let's prove it. All right, so the first thing that we can do, if you're given the parallelogram, the only thing up to this point that you know is then EF is parallel to HG, and EH is parallel to FG. Okay? That would be because of the definition of a parallelogram. Okay? All right. That allows me to see that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Why? Because of the alternate interior angle theorem. The alternate interior angle theorem. All right. Then we added that reflexive side, okay, right? So we did EG congruent to EG by reflexive. And if we go through all our pieces, we've actually got the two angles, right? Oops. An angle and a side. So I'm ready to prove the triangles are congruent. So I can do triangle EGH is congruent to triangle GEF because of angle, side, angle. All right, so now the triangles are congruent. Does that give me the corresponding parts congruent? Is EF congruent to HG? It sure is. So EF, segment EF is congruent to segment HG, and FG, segment FG, is congruent to segment EH because of CPCTC. All right, so basically, guys, what you guys just did was you proved that opposite sides of a parallelogram are congruent. It is a theorem, but we're not gonna give it a name. We're gonna actually state in proofs opposite sides of a parallelogram are congruent. We're gonna use the whole statement because it's just easier. All right, so now how do we use that? All right, so I'm gonna do example 1, and then we're gonna do example 2 and 3 in class. Okay. So I gave you parallelogram ABCD. So the first thing I'd want to do is draw it. So I'm going to draw AB. Oh goodness, sorry, AB, C, and D. Now, I don't want to start marking everything right away because I want to be careful that I use what I need. So I mark what I have first. And it says that AB is 2x plus 1, and that DC is 4x minus 19. So I see it's a parallelogram, and I see that I'm dealing with side lengths. So what I'm going to do is I'm going to actually use that theorem above. Opposite sides of a parallelogram are congruent, so I'm going to mark them congruent to themselves. And then it helps me write an equation to solve for x. So I can write the equation 2x plus 1 equals 4x minus 19. And then I can subtract 2x and add 19. So 20 equals 2x and x equals 10. So that's how we used the property that opposite sides of a parallelogram are congruent. All right. On to 2 and 3 we're going to do in class tomorrow. Theorem property number 2, okay? Now, I'm not going to actually go through the proof of this one, but I am going to talk to you about we could prove it the exact same way. We'd go through the exact same proof. We'd prove the triangle's congruent, and then we'd show that the opposite angles of a parallelogram are also congruent to each other. So opposite angles of a parallelogram are congruent. And when I say opposite angles, let's make sure. If this is parallelogram ABCD, A and C are opposite to each other, and B and D are opposite to each other. So B and D would be congruent, and A and C would be congruent. So it says in parallelogram ABCD. Sorry about my diagram there, guys. It's terrible. Let me fix it if I can. All right. That's a little better. ADC equals 42. So ADC is this angle right here. Is 42 degrees. Find the measures of the 3 other angles. All right, I really need to fix this parallelogram. Sorry. It's just bothering me. It's got to look more like a parallelogram, and it doesn't. So A, B, C, and D. All right, so it is a parallelogram, and I know that opposite angles of a parallelogram are congruent. So if I know that this is 42, then I know that this is 42. All right, so that helps me, right? Now I also know A and C are equal, but I don't know how to find them. All right, so let's talk about that for a second. We know that the definition of a parallelogram is that opposite sides are parallel. So I'm going to now use the definition to help me find something further. So if opposite sides are parallel, then these 2 angles, angles A and D, are on the same side of the transversal, so they are supplementary. They're same side interior angles, and they're supplementary. So I can do 180 minus 42, which gives me, what is that, 138. So angle A is 138, and angle A and C, opposite angles in a parallelogram, are congruent, so that means that angle C is 138 degrees. Okay? All right, so we're going to do the next 2 examples in class tomorrow just to make sure everybody understands it. And now we're moving on to the next theorem. All right, theorem property number 3. All right, the diagonals, so the lines that go through a parallelogram, they bisect each other. All right, so bisect means cuts into 2 equal or congruent parts. Okay? All right, so let's draw a parallelogram. E, F, G, and H. Okay? All right, so in order for me to say that the diagonals bisect each other, that means that here are the diagonals. In order for me to say they bisect each other, I need to get to a point where I can say that EX, I'm going to put an X in the middle for that intersection point, okay? That EX equals XG, or is congruent to XG, and HX is congruent to XF. All right, so again, I'm going to use the concept of congruent triangles, but I might have to do it a little bit differently, okay? All right, so I need to prove that EX and XG equal each other and HX. So I can either use these 2 triangles or these 2 triangles. So I'm going to use the ones that we're straight on looking at. So I'm going to use triangle number, I'm going to call it 1 and 2. Okay, I'm going to use those guys. All right, so number 1, it is a parallelogram. E, F, G, H. Okay, so that's given to me. So that tells me, number 1, that the sides are parallel. So I'm going to mark those. I also know that in a parallelogram that opposite sides are congruent. So I'm going to mark that congruent to that, and this guy congruent to this guy. All right, and then I'm going to help you by putting in a 1 here and a 2 here. Okay, so because I'm trying to prove triangles 1 and 2, I know that angle 1 is congruent to angle 2 because of the alternate interior angle theorem. Okay? And then I also see the vertical angles right here and right here. So looking at this, I can prove the triangles are congruent by angle, angle, side. So I'm going to have to do that, and then I can prove the segment's congruent. All right, so step 2. I would say that EF parallel to HG and EH parallel to FG. Okay? All right, and so that would be because of the definition of a parallelogram. That gave me that angle 1 was congruent to angle 2 because of the alternate interior angle theorem. Okay? I also could say that using my diagram just a little bit more, okay? I can also say that EH is congruent to FG because opposite sides of a parallelogram are congruent. And then I can say that the vertical angles, and I'm going to call those 5 and 6. So I'm going to label 5 and 6. Angle 5 is congruent to angle 6 because of the vertical angle theorem. So therefore, the triangles are congruent, okay? So 6 and 6. Triangle, let's see. Triangle EXH is congruent to triangle GXF, right? Because of angle, angle, side. And so then that gives me that EX is congruent to XG and HX is congruent to XF. I reached my goal. Oops, that's 7, step 7. Because of CPCTC. So does that mean that they bisect each other? It does. So step 8 would be that EG and HF bisect each other because of the definition of a bisector. Okay, so just to recap, you know the definition of a parallelogram is a quadrilateral with opposite sides parallel. You know that opposite sides in a parallelogram are congruent, opposite angles in a parallelogram are congruent, and the diagonals bisect each other. So you are going to want to read through those for tomorrow. Now we still have more to do on this lesson, so I am going to be finishing this up tomorrow, but I didn't want this to go too much longer. Have a great night, everyone.